Good morning, Parthiban sir.
Morning.
Ah, okay. Good morning, one and all present here. This is a time to introduce our chief guest, Parthiban A, team lead, business development. He's a tech enthusiast, people person, and got placed in Infosys, but he did not take up the offer as a decided to work in startup related to his core branch of electronics and communication engineering. He started working in tech education startups and shared knowledge and motivated students through guest lectures and workshops, and he was very passionate about education. He has conducted sessions in more than 50 colleges in Chennai, Coimbatore, Bangalore. He has done his master in embedded system technologies from College of Engineering, Anna University. He is a tech enthusiast and worked on several projects related to technologies such as robotics, embedded systems, and Internet of Things. Currently, he has more than 8 years of experience and heads the business development team at Lema Labs, incubated at IIT Madras Incubation Cell. He has handled the social media accounts of Lema Labs and run campaign in Facebook, Instagram, and Google Ads. He is an all-rounder in technology, sales, and cricket as well. He spends his Sundays playing cricket and have represented Anna University Chennai team in South Zone. On behalf of Sri Saram Engineering College and Department of Computer Science and Engineering, I welcome you, sir. Over to you, sir.
Thank you. That was a brief and uh, very elaborated introduction, I would say. Thank you. Thanks for the introduction. And good morning to all the participants who are here. I could see around 56 participants, so maybe leaving Sairam 6 faculties, 50 participants are there. And a very good morning to everyone. And trust me, like
Good
this,
morning.
yeah, morning. So this entire week, I believe you guys would have gone through a lot of concepts related to IoT, the trends, and how different technologies like machine learning can be used in IoT and so on. My like session, the two sessions that we have today, will be focused more towards how you can yourself get started into IoT and build IoT related stuffs at your home, at your colleges, or guide students who are working with IoT related projects in your colleges. So that is the whole idea. So without further delay, let's get started. I hope the screen is very clear to everyone. Yes. Okay, one more thing. I would love to get some interaction from the participant. I know you guys are faculties, but still, I would love to get some answers, maybe in the chat, or you can unmute yourself and then give your answers, so that it's more of a knowledge sharing session than someone sitting on this side and then delivering something. So I would appreciate if you can unmute yourself and answer whenever required. So not everyone, maybe someone who's very comfortable with answering, right? So let's get started. So why there is so much focus about Internet of Things at this moment in the world is because of something that you see in the screen. So I'm damn sure you should be very aware what these are. So these are the industrial revolution that have happened so far. So you very well know the first industrial revolution started because of the invention of like steam engine, I would say. And then with mechanization, we were able to make production in the industry and the way things are being produced everywhere. And then the second industrial revolution happened because of electrification, electricity, motors, and then you were able to grind so many things, and then production were happening with much of only electrification. And then the third industrial revolution started because of electronics and then a little bit of computer science as well, when we introduced microcontrollers, programming, and then PLCs and so on. So it pretty much, it's a combination of hardware and software, where you were able to control with the programming and the way production were happening in the industry. And at the moment, everyone is talking about something called Industry 4.0, right? So Industry 4.0. So that is where we are heading to. So to let you know what is Industry 4.0, I know you would have listen to so many people. So then I'm telling what is industry 4.0. If I could play a simple video from a very well-known brand, it would help you to understand what is industry 4.0 in a very better way. So let's have a look at this video.
New technologies are changing the world. They're also making the cars manufactured by the Volkswagen Group more efficient, safer, and more customer-friendly. The nature of car manufacturing is also changing in a similar way. In fact, the next batch of innovations is so extraordinary that experts are already declaring the dawn of a new industrial era, Industry 4.0. So what does manufacturing look like today? Traditional car production involving hundreds of identical vehicles lined up in a row no longer exists. The options available to customers are now so vast that each car becomes a unique and individual object. Cars are now manufactured to order. Data makes its way from the customer's order to the Volkswagen Group's systems and then to each individual section of production. A car consists of many thousands of individual parts. The press shop processes blanks for the bodywork. In the body shop, the car is baptized. In other words, it's given an RFID tag that can track it via radio frequency. This establishes which car body belongs to which customer order. The paint shop also receives information from the system world. In sequencing storage, the cars are placed in an optimal order for assembly. From here, information is transmitted to suppliers and pre-assembly as to which part is required when and where. In final assembly, the finished car emerges. The Volkswagen Group manufactures its cars using state-of-the-art technology, but development and innovation never stop. What does the future hold in store? Today, everybody is talking about Industry 4.0. It is a term used to describe a variety of innovative production processes. But what exactly does it mean? The Volkswagen Group has been shaping the future with groundbreaking projects for many years. Here are some recent examples. Digitalization. The digitalization of all elements of production is essential for a new era in industrialization. Everything is given a virtual likeness in the system world. The result is an Internet of Things. Example, 3D printing. Pressing tools are no longer shaped in a laborious manner. Instead, these tools can be made from steel granulate in a 3D printer. It's a technology that opens the door on completely new possibilities for design, with a level of precision unknown until today. Example, human-robot cooperation. In the past, protective grids separated robot arms and employees. In the future, employees and robots will work increasingly hand in hand. This is made possible by new security sensors. Robots take on especially monotonous and arduous activities. Today, robots already play a part in contributing to ergonomic workplaces at the Volkswagen factories in Chemnitz and Salzgitter. Example, Big Data Monitor in logistics. The Big Data Monitor enables for the rapid visual processing of data from the 1,200 suppliers of the Audi factory in Neckarsulm. Where are the potential bottlenecks? Where is the greatest need for action? This data is now easily accessible at all times. The intelligent factory of tomorrow paves the way for efficient and cost-effective production unlike ever before. Industry 4.0 also means brand new opportunities for employees. The Volkswagen Group has already begun actively preparing its workforce for the future. The world is changing, not only in the automotive industry. Everything is in motion, and the Volkswagen Group provides the technology that moves the world.
Yes, so that's Industry 4.0 for you. So Industry 4.0 is basically like combination of technologies, I would say, Internet of Things, and then data analytics, and then artificial intelligence, robotics, everything put together would be your Industry 4.0. So it's a combination of technology where each machine can communicate with other machine and then to the control unit, and then the production becomes more interconnected and smarter. So that is Industry 4.0. Even in the production of cars and automobiles, no more thousands of identical products are being produced in the industry. So each customer, we as a human being, as a customer, can tell this is how unique I want my car or bike to be. Even Royal Enfield have launched like you can choose to design your engine guard, the seat, the alloy wheel style, and then the silencer, everything. So this data is fed into the production unit, and then each vehicle is identified by an RFID tag, and through the RFID tag, the entire production process is being taken forward. So this is how Internet of Things and smart systems help us in the fourth industrial revolution. And also the other side for the industries, the way things are being monitored, the controlled, and then predicting the failure of a mission or predicting the accuracy of the production, everything is taken care by the other sides of technology as well. So this is Industry 4.0. Industry 4.0 at industries. So not just industries, not just at production, even at homes, things are getting changed. So how things are getting changed at homes is, this is how. Yes. So this is how. Okay. Thank you. Thanks for meeting. So this is how you can expect the gadgets at our homes to be IoTified in the future. By future, I don't mean 10 years, 20 years from now. Already many of these products are in place, you know. So things can communicate with each other. You can control a lot of gadgets with your smartphones. A lot of things are there happening. So you can expect IoT to change or revolutionize the way gadgets are being at the moment. So you can expect it to happen within a few years of time. So that is what is expected from the industry side. So now coming to the main point. So what is IoT? What is Internet of Things? And I'm sure you have been spending the 4 days and one more day on understanding what is IoT. So what is IoT according to you? Anyone? Can anyone answer what is IoT? Maybe you can fill up the chat also if you wish.
Participants, you can unmute yourself and tell the answer, or else you can put the
Yeah,
answer
IoT
in the chat
basically
box.
it's internet over things, and means it's if a machine is connected with the internet, if a human being is connected with the internet, and so on, we can say that it is an internet over thing. Means anything um, which having a human intelligence also equivalent to the human intelligence also is come under the internet over thing.
okay, you're almost there. You're almost there. Thank you. Thanks for answering. All
Thank you.
right. So it's very well said. So what she wanted to convey was, see, we as a human being have five wonderful senses. Correct? What are the senses that we have? We can see, we can hear, we can taste, and then we can feel, and then uh, maybe we can Einbulan. So I'm not sure. Like the other one, I missed it. So the ability that we have after sensing all this thing, we can communicate it to the world, right? So the same thing, if you are able to give it to any normal gadget, normal thing, the ability to sense and then to communicate, and that particular gadget becomes intelligent or smart like a human being. Agree? Yes. So same thing applies here. So the internet that we had in the past, it was like more of internet of the people, yes, for the people and by the people. Like a democracy, the internet that we had in the past was only for we human beings. But now we human beings are so generous that we can even make a normal gadget, normal thing also to get connected to the internet, and then it can sense and it can also communicate like how we have been doing using the internet. So that is Internet of Things. So Internet of Things, basically the ability, yeah, very well said. Someone Yoganan, like Internet of Things, it's a system. Yes, great. So to keep in a very simple word, so at Lemalas we always keep things very simple. So to make you understand what is IoT in a much better way, it's very simple. To get IoT, all you need is smart devices. So smart devices are devices. A normal device can be made smarter if you give them two abilities. So the two abilities are nothing but ability to get connected to the network, like how we use internet to get connected with each other, right? The same ability, if you give a device with the capability of getting connected to a network, it can become smarter along with one more characteristic, that is the ability to share and collect information. That is like how we human being collect information with all the five senses that we have, and then sharing happens through our uh, words or through the gadgets. You share, you see something, you share it in the social media with people, or you send an email, something like that, correct? So any device can be made smarter if we can give them the network capability and also the ability to collect and share the information over the network. So examples of smart devices. Can anyone give some examples of smart devices that you know? Any smart
Fitbit,
devices?
Fitbit.
Fitbit, exact, wonderful example. All the like smart watches and Fitbits, exactly, and smartphones, exactly. So this is the first smart device that comes to our mind, exactly. And all wearables includes the Fitbits, the iWatches or Motorola watches or Samsung gears, everything, and of course, exactly, smart locks and other. Exactly, you guys are there. So to give you example from my end, not just Fitbits and smartwatches. You guys know what these gadgets are? Amazon's Echo. That is, there is a personal assistant in it called Alexa, which can talk with human beings and collect and share information using internet. So not just Alexa from Amazon, we have from other companies as well. Like Google has its own home part, Apple has its own speakers with personal assistant Siri. So a lot of things are happening. And as you guys said, all smartwatches and Fitbands comes as smart devices. So these are smart devices. So what is IoT is, when these smart devices talk to each other over the internet, then it becomes Internet of Things. As simple as this. So IoT is basically smart devices, any device it can be, which has network capability, which has ability to collect and share information. When they talk to each other, when they get interconnected to each other, when they communicate with each other over the internet, then it becomes Internet of Things. So I hope everyone is clear with what is IoT now. And to proceed further, everyone is talking about IoT, but have you ever thought, is IoT is real and it is being used in places today? Yes or no? Do you think IoT is actually used? Yes, exactly. So yes, it is being used. So where where comes the exactly? So starting from Yoganan's answer, yes, at homes IoT is used, and the way education is being done at the moment, virtual environment. So things have changed lot of in lot in education side. So there also, with respect to results, with respect to classes being conducted nowadays, with respect to attendance being collected, IoT is being used. And industries, of course, smart grid, energy, healthcare is one of the major sector that is predicted to be having a very kind of revolution in with respect to the way gadgets are at the moment, or the testing devices are at the moment. So we expect IoT to take care of healthcare in a much better and efficient way in the coming days. And mobility, that is automobiles and other uh, bikes. Even bikes have mobile connectivity nowadays using Bluetooth, or you can have a navigation system in your bike. So things are changing there as well. And retail, yes, the way we shop also is going to change. And agriculture and government sector are where areas IoT is currently used. So now, if you want to get started with IoT, so you know what is IoT, and you know what are all the applications of IoT. But as a faculty, when you wanted to get started with IoT, trust me, I'll take you from the very basics, because I'm a person who always believe a foundation is very important than having a overview of things. So today we will focus more on getting that foundation right. And trust me, end of the session, you can also go and guide a lot of students on projects when they work related to IoT. So that is the whole idea today. So now, if you want to get started with IoT, what or where you should get started is, the first step I would say is somewhere here. So somewhere here, in the sense, the controllers and processes with network capability. So that's where we have to first get started with. So this is the first step that we have to start with. So as a faculty, it is very important if we can start getting a microcontroller or a processor that has network capability, and then start exploring it. And then second knowledge that you might need is how to work with some sensors and actuators. So that is, sensors are the devices that gives the ability to collect information. That is, you have to collect information from the environment. So if you know how to work with sensors, and then also have knowledge how to control actuators like motors, displays, and everything. So that is one side. And apart from that, IoT is more of not just local networking. You should know how to do these two steps, that is, sending information to the cloud and retrieving that information from the cloud and doing something meaningful. So if we have all these knowledge, that is a knowledge how to work with a microcontroller or a processor with network capability, and to work with some sensors and actuators, along with the knowledge how to send some sensor data to cloud and retrieve that sensor data from cloud, trust me, you can build any IoT projects that your students are wishing to build, or any IoT related projects that you want to do as a research or a hobby project, or something you want to automate at your college or at your homes. So that is possible if you have this knowledge. So I'll be taking you through all these in the 2 sessions that I'm going to deliver today. So first, let's get started with the first important thing. That is, when you want to work with IoT related projects, so first thing that you have to learn is a microcontroller that has network capability, right? And with respect to IoT, the most commonly chosen devices are the two in your screen. First one is a Node MCU, which is a ESP8266 Wi-Fi enabled microcontroller. What it is a Wi-Fi enabled microcontroller. And the second one is a Raspberry Pi, as everyone knows. So Raspberry Pi, a very high fund application, something where you need a computer like device to do the controlling and processing. You can go for a Raspberry Pi, but most of the cases you can finish the application with a Node MCU itself. So now, what are the other boards? Are Node MCU and Raspberry Pi are the only devices available for you? No, we have a lot of very well-known devices available in the market as well, like ESP32, which is an advanced version of ESP8266, because this has both Wi-Fi and a Bluetooth connection as well in the board itself. So for wearable technology, it is recommended to go with ESP32. And then we have other boards like BeagleBone, Tessel, Intel Edison, and also even Texas Instruments have a lot of boards. And apart from that, when companies design products, they won't choose boards like this. They will definitely choose a platform to work. That is, either they will go with STM, ARM microcontroller, everything, which software can be used to device connection. So through the session, I'll definitely help you understand how you can write program, connect devices, everything. So please be patient and listen to the session. So now, the board that we have chosen today was a Node MCU. So why we are choosing a Node MCU is, and I'm sure your students would have taken an Arduino board and come to you showing their projects for so many years now, right? So Arduino is the most commonly used open source platform when they work on a hardware related project, correct? So with Arduino, if you give a Wi-Fi capability, that is equal to a Node MCU. So Node MCU is an open source platform again, and it has an inbuilt Wi-Fi chip in it, and you can program it using Arduino. Not just Arduino, it supports many other programs like Lua script, even embedded C also you can program. But you can program it using Arduino as well. So people prefer a Node MCU development board because of these reasons. So this is very true, isn't it? Even for the last 10 minutes, when I start talking, and when you listen to an webinar, we lose our patience, and some, like, we put our systems down or keep our phones away, and then we feel very tired and then feel exhausted, right? So let me try making it more interesting and interactive if possible. So what you're going to learn today, practically in the sense, you can definitely try out after the session. Even some of the parts, if you are having a system with you, you can try parallelly as well, and then see if you are also able to work and design like how I'm doing from here, showing the demo, right? So what you will learn through the session today is, first thing, so software, someone was asking, what software should I use to work with IoT, right? So today I'll teach you how, how you can program an OpenCU microcontroller board. That is the first knowledge that I will share with you. Who is it? Can you please mute your audio? Okay. Second thing, we will also go into IoT over local networking. That is without internet, in a local Wi-Fi network. How you can control devices using web pages. So that is what the second thing that I would be sharing with you. And third one, than web pages, won't it be cool if you control devices with your smartphone using an app? So I'll teach you how you can build some simple Android application using MIT App Inventor platform today. So that is the third thing that we will see. And fourth step is very interesting. Fourth and fifth are IoT over internet. So using internet, how you can connect a sensor to microcontroller Node MCU board and push this sensor data to a cloud server like Adafruit IO, Google Firebase, AWS, or a lot of servers are available today I'll be covering one of them, right? And second thing is how you can subscribe that sensor data, retrieve that sensor data, and control devices from anywhere in the world, right? You have your smartphone at your home, you can literally turn on a bulb or a fan that is there in your college, or turn on something in your college or something somewhere else. So that is what I'll be teaching you in the last part of the today's session, right? So interesting. So this is what we are going to learn today. So now let's get started with a node MCU. So what is node MCU is, I have here. So a node MCU is a Wi-Fi enabled microcontroller development board. The exact microcontroller in it is ESP8266. If anyone wants to remember, you can remember it. ESP8266 is the Wi-Fi microcontroller present in the node MCU, and it has all the very necessary, I won't say everything there, all the necessary interfaces that you want to build IoT projects now are present there. So it has a reset button. So whenever the microcontroller gets hanged, you just press the reset button. It takes you the program to from the beginning. And it has a micro USB port through which you will program this microcontroller board. And also it is used to power up this particular board. And apart from that, it has all inputs and outputs pins here, right? You can see the pins that are here. So you even on the screen you can see the breadboard connection. So here you see a lot of pins, right? So those are the pins to which you will interface your input and output peripherals. So got it? So it has a Wi-Fi enabled microchip in it, and then it has all inputs and output peripheral interfacing pins in it. It has some inbuilt LED, reset button, and a micro USB to quickly program and power it up as well. So this is the highlights of a node MCU microcontroller board, right? So these are, and the reason I have already told why we can choose a node MCU board is simple reason. It's an open source device, Wi-Fi enabled. You can program it with Arduino, and it is also cost effective. So this board will cost you somewhere around 300 to 350 rupees, not more than that. You can get a board, have it with you, start building a lot of interesting IoT related applications. So now, to learn how to program this particular board, you have to learn Arduino programming. I know it's very beginner level. I'm not sure how many faculties here have already worked with Arduino or having knowledge about how to work with a Arduino board or a Node MCU board. But please be patient if you have already having knowledge on this. So this next 5 minutes will be very useful for people who are getting started. So every Arduino program has two functions. The first function is setup, and the second one is a loop. So what is the first function? Setup. Second function is loop. So in setup, what you generally do is you do all initial setups like making pins input, making pins output, configuring something, and anything that you wanted. Okay, SECS 71 raised your hand. What's the question? Or have you put it in the chat? No, it's not there. Okay, so maybe you can leave your question in the chat. I'll definitely try answering. So setup is a function where you do all initial setups like making pins, inputs, outputs, configuration, everything. And remember, setup will be executed only once. So whatever you write in the setup function, it will be executed only once. So that is setup function for you. And the next one is, how do you do things in the setup function? For example, let's say first task today, what we are going to do is, let's assume we have a LED here on this node MCU board. We are going to work with that LED today. Let's assume that, right? So now LED, is LED an input device and an output device? Can anyone answer? Is LED an input device and an output device?
Output device.
Great.
Output device.
Great. It's an output device. So first step in setup function, what we have to do is we have to make that particular pin where you are going to connect the LED as output. So how do we do it in Arduino is a question. So how do we do it is using the function that is there on your screen, pin mode within bracket, whatever pin that you're going to connect your Arduino or Node MCU LED to, and then comma the mode, whatever you want to. If you want it to be output, just write output. If you want it to be input, just write it as input. So the exact answer, if you want to make the pin 16 where the LED in this Node MCU is connected to an output pin, the function or the command to do that is pin mode within bracket 16 is the pin number, comma output is the mode that you wanted it to be working as. Clear? So now how will you make it work as an input pin? Suppose if you want to, so very simple, how you can make it is pin mode within bracket the same pin number comma input if you want to make it work as a input in a later or a different program. Got it? So this is how you make a particular pin input or output in Arduino programming. Correct? Got it? So now next thing. So the other function that is there in Arduino is a loop function. So what is a loop function is? A loop is a function that will run endlessly or that will be executed infinitely. So whatever you want to work continuously in your project or in your application, you keep it inside the loop function. Let's say for example, I want this LED to glow continuously. So all you have to do is make that pin in output and then write the program that is required to turn on the LED and keep that inside the loop. So the LED will be continuously on if you do it. So how to so LED on, if you put it here, it will be continuously turned on. But this is not the exact way to turn on the LED. I'll teach you. But assume whatever you want to run continuously, you should write those set of programs inside the loop function. Clear? So setup loop. Is it clear? Yes. So let's hope it's clear. Now, in our case, let's say the pin 16 is where the LED is connected in the Node MCU. Now you need to know in order to turn on that LED, how should you turn on that LED and how should you turn off that LED, right? So if you're not aware what are the pins of a LED, LED has two pins, a positive terminal called anode and a negative terminal called cathode. So basically it is a diode which works when you give a higher potential on one side and a ground on the other side, creating a potential difference. So in our microcontroller, how it is connected is a 3.3 volt is connected to the positive pin and the negative terminal is connected here. So it has a positive supply already to the positive pin and you're going to control that LED with the pin number 16 here connected to the negative of the cathode. So now to turn on that LED, already one side positive, high voltage is there. To turn on that LED at pin number 16, what value or what logic you have to do is, you have to give a low signal or 0 volts. So if you do this, that LED will definitely turn on. And if you want to turn it off, already on the other side higher potential. So if you make the other side also higher potential, what happens is there is no potential difference. The LED will not be turned on. As simple as this. So now if you want to turn on the LED, you have to give a low signal. So low is in Arduino, you can simply write it as LOW. That will give or make that particular pin value 0 voltage. Clear? Now if you want to make that particular pin value high or 3.3 volts, you have to give a high value. So this is, so in our case, when you give low signal, the LED glows. When you give high signal, the LED turns off. Clear? So this is how you do it. Now in programming, how do you do it? That is a question, right? In programming, Arduino program, it is very simple. All you have to do is use digital write. Digital write. So I'll definitely recap once, that time it will be a repeat. So how to use digital write is, suppose if you want to write a particular program in okay, in our case, pin 16 is where the LED is connected. So to turn on that LED, you have to make that particular pin low, correct? So how do you make that pin low is, digital write pin comma, that is pin is 16 comma low. So this will turn on the LED, and to turn off that LED, digital write 16 comma high. Clear? So this is how you give 0 volts or low signal to particular pin in the Arduino or even Node MCU microcontroller board. So what we have seen so far is, in Arduino programming, we saw two functions. What are they? Setup and loop, correct? Yes, exactly, loop. So now in setup, what you do generally, you do all initial input and output declarations, and then configuration. It will run only once. And the next function we saw was loop function. So loop is a function that will run endlessly or infinitely, correct? So now how do you make a particular pin as input or output? Which command will you use? Anyone? Anyone who can answer?
Pin node
Pin
in
mode,
in
bracket.
bracket, particular pin, comma, output or input.
Great. So exactly. So in our case, we are going to use pin number 16. So we make it pin 16 comma output, since LED is connected in the pin number 16, right? So it is an output device. So we make pin mode 16 comma output, correct? So now the function that is used to make the value high or low in a particular pin. So which is the function that we use, or command that we use? So how do you make a value high or low of a pin? Which
Digital
command will you
write.
use?
इनपुट ले रहे हैं उससे आप कुछ
Digital write.
Exactly. So digital write the pin comma value. So
Value.
if you want to make it low, you write low. If you want to make it high, you write high. Great. So now let's go to the direct programming. So now first task that we are going to do is, we are going to turn on this LED. So simple. First setup function, void setup, and then you make that pin 16 as output. That is there in your screen. You are very clear with this, correct? So now in loop function, you have to turn on this LED and it will run continuously. So to turn on the LED, digital write 16 comma, can anyone fill it up? Digital write 16 comma to turn on the LED.
Output.
Digital write 16 comma
Low.
Exactly. So if you write low, the LED will be continuously turned on. Clear?
Yes,
so this is how you write a simple Arduino program to do or control a certain hardware. Now let's see it practically, because it would be interesting if you see. So let me share my Arduino screen as well. To program this particular board, all you need is this board and a micro USB cable, which you get in your phone charger as well. We can use that. So you can easily do that, right? So now the steps, you're able to see the Arduino window. I hope you are able to see the Arduino window. Now, this is an Arduino software which you also can download it. It's a open source free software. You can go to Arduino website and then download it and then install it. Everything will be ready for you. And then once it is okay, you can't see the.
Sir, Arduino window is not available.
Okay. One second. Let me change the screen share. I think I was sharing. Okay, now
It seems.
Yeah, now it's
Yes, sir. Yes, sir.
great. Okay, so the first step to start working on an Arduino project is go to File, New, very simple. These are basics, but still, if anyone is interested to work further, right, it would help them. So that's why I'm spending some time. So you get a project like this, very simple. All you have to do is, first, in our case, we have to make pin 16 as output. So I'm doing that there. And then in loop function, we are going to turn on that LED continuously. So digital write 16 comma low. This will turn on that LED continuously. As simple as this. So this is how you write a program in Arduino window. And the next steps are go to file, save. You can name your file with anything you want. I think already Sairam will be there. Sairam Institute is there. So let me keep it Sairam now. So Sairam, right? So after these steps, the next important steps in any integrated development environment. Okay, that's very informative. Please go slow or repeat. Great. If you are really interested in learning all this stuff from the basics, I can definitely repeat and make you learn in a slow and very steady manner. Okay, I'll do that. So now once you type the program, all you have to do is save it. And then after saving it, all you have to do is the first step. As a computer science faculty, you know, you will be compiling the file, right? Any programming that you do, you compile it. So in Arduino, the way you have to compile is this particular tick. So when you click it, you will see here compiling sketch in the below taskbar, right? So compiling sketch. So what happens is this Arduino program will be compiled, will be converted into a machine understandable code, and then also it will check for errors. So that is what happens when you press compile. So done compiling, you don't see any errors. Suppose if people wants to see some error, let's leave a semicolon and then type. See, this is how Arduino window shows you errors in the program. So compile it. Done compiling. So the next step is very simple. Connect your USB cable to your computer and then plug it to the micro USB port. And since you guys are very interested, things to remember when you are first time plugging in the Node MCU, right? First thing that you have to do is, so you have to check if this driver for the USB device is installed or not. So in my case, I have already installed it. So it would be there under ports. If you see here, COM5, Silicon Labs CP210X, USB to UART serial bridge COM5. So I have already installed the driver. So it is available for me. Suppose if you are buying it for the first time, you have to find which USB to UART chip is there in your microcontroller board and then install that particular USB to serial drive, right? So next step, before sending the code to the Node MCU board, you have to check a few things. This is very important. Go to tools, and then check the board. First step is checking which board you are programming, correct? So which is a board that we have today? I repeated many times. We have Node MCU ESP8266. So here it is. ESP Node MCU 1.0 is the board that we have with us today. So similarly, you get to program a lot of boards with Arduino programming. So you have to choose your board that you have with you, correct? Next step, you have to come to this port. So here you have to select to which COM port you found your device getting connected in computer. So in our case, when I opened the device manager, you saw it was connected to COM5, correct? So you have to select that particular COM port. So now after checking these two parameters, how you should upload the code to the Node MCU board is just press this upload arrow button. So when you press it, it will get again compiled, and after compiling, so if you see here, the program is getting writing at some address, right? So that will have to go to 100%, and you will see a red color LED on the Node MCU turned on when the program is complete. Able to see the red color LED on the top right?
Yes, sir.
Yes. So this is a simple way. Trust me, if you have a Node MC and a USB cable at homes or colleges, you can do a lot of interesting IoT related project. So now let's quickly make it blink so that you get an idea how like when you write a different program, how you have to upload it again. So to do that, let's do this activity. Let's try making it blink. So what is
Given
blinking?
the
What is
given the
blinking?
extension,
What is blinking?
if you given the delay time,
Yes, exactly. So if you give a delay for on, and also it has to turn off. So what is the command to turn it off? 16 comma.
High.
Wait, if you write high, it will turn off. And if you want to see blink, you have to give a delay to the off time as well. Only then it will be blinking, correct? So let's turn it off for another 1 second, correct? And also I want to show you another interesting thing here. So let's say you wanna like communicate something from this board serially to this particular Arduino software or anything serially. So that is also possible. It is very simple. So how you can do that is, it is serial communication. So I believe you guys know what is serial communication. So serial communication is you have two wires, RX and TX, where like data is transferred bit by bit or one after another in a single channel. So from TX to RX it goes, or RX to TX it comes, right? So how to configure serial communication in this Node MC or Arduino board is very simple. Serial dot begin. If you give a particular baud rate, okay, so this is nothing but baud rate. Baud rate is basically you have your Wi-Fi connection now, so you get it at 150 Mbps, and then or 100 Mbps or 75 Mbps or BSNL network 512 kbps, something, right? Same thing here. So this is nothing but the speed at which the communication is going to happen between the laptop and the node MCU. So 9600 bits per second. And how do you transmit value is, so S should be capital, serial dot print. Now let's say the LED will be turned on here, right? So let's send a string called LED on. When LED turns on, it will display LED on. And when it is turned off, clear? So what we are going to do is, when the LED turns on, we are going to send serially a data called LED on, a string LED on. And when it turns off, we are going to serially transmit LED off to the computer from the node MCU. Same process. After writing the program, you need not save it again, because if you simply compile, it will be saved and then it will be compiled. Even compiling is not necessary. You can directly go and upload, because when you click upload, it compiles and then it uploads the code, right? So now it is getting uploaded. %. So you should see your LED blinking, and when it is blinking, you should also see the value transmitted. So what is the baud rate that we used? 9600, right? Okay, one thing that we missed is it's printing serially one after another in the same line. So being a programmer, you very well know how to make it come to a new line, right? So if you make print ln, it comes to a new line. So let it get uploaded again. So now you see, okay, I have to give to both, else it will happen. So you can play around with Arduino if you want. So every time it comes, it will come in a new line if you add ln. Clear? Any doubts so far with respect to how to type a simple program?
सर ये जैसे अभी आपने com5 पे शो किया था that it comes serially. Sir, will you please show it again that how it comes serially when I'm not putting the ln?
Okay, so if you're not putting ln, so now you see with ln, I'll show you here. Let me reset it. So with ln, both the places you will get the values printed in new lines. So LED off, LED on comes in new lines. So this is
This screen, I just want to know that how you are going to com5, from where you are going to show this thing.
okay. So com5 in my device manager, if you notice here, so this particular USB cable is connected to the USB port, and every time you connect any devices like printer or any USB gadget or anything, each device will be assigned a communication port in your computer. So this particular device has been assigned COM5 in our case. So the same COM5 you have to use when you are programming your Node MCU. So here if you see tools, so see here I have selected COM5. So when you open the serial monitor also, it will open up the same COM5 because that is where the board is connected. Understood?
Okay, sir. Okay, sir.
Yeah. And without ln, it will be coming in the same line. Let's say you want to monitor a sensor data, and that sensor data will be sending some random numbers, right? If you don't print it in new lines, you will not understand what number it is sending it to you. So it becomes very difficult for you to recognize. So always having a new line will help you sort out and make it easy for you to visually understand. Got it?
Yes, sir. Thank you, sir.
Sure. Welcome. So this is with respect to basics of Arduino programming and how to program a simple Node MCU development board. So if you have a Node MCU board with a USB cable and an Arduino software, trust me, you can start building a lot of interesting IoT application. So the next application that we are going to do today is, let's do IoT related stuff now. So what we are going to do now is, we are going to have this Node MCU and we are going to do some programming in it, and we are going to create a web page with two buttons in it, LED on and LED off, and we are going to create a local network between them. That is, the Node MCU will create a Wi-Fi network for you, to which you will get connected using your smartphone or your laptop. And by using these two buttons, when you press LED on, you will turn on the LED on the Node MCU, and when you press LED off, you will be turning off the LED. Interesting. So what we are going to learn or understand now is, you are going to create a server or a like access point or a local network on your Node MCU, and create a simple web page with the two buttons in it. And in the local network, you are going to control the LED with the buttons on them wirelessly. So that is what we are going to learn next. So how do we do it? So first step, we have to write a simple HTML program. So what is HTML? Hypertext Markup Language. Yes, it is a language used to create web pages. So we would have started learning all this thing from our school days itself, correct? So to put in a simple way, so hypertext markup language consists of two parts. One is hypertext. You know what is hypertext? Any text or anything that with a link to it, correct? So that is hypertext. And then other one is a markup language that is used to add all videos, photos, graphics, everything to the web page. For example, if you open up our website, this is our old website. If you open up our website, when you go and click something, it opens up a new page, correct? So there is a link that is hidden in that particular text. So that is hypertext. A text with link in it is called hypertext. And what is markup language is, it is used to add or make text, images, links, web pages, and much more in the HTML programming. So that is why it is given a name HTML programming. So now you very well know, being in the CSE background, you very well know all HTML program are done between tags, opening tag and closing tag. And you know, when you start something, you use a opening tag, and when you close that particular thing, you use a closing tag. And elements of HTML tag are something but nothing but that comes between the tag. So for example, anything that you want to print, or any title that you want to give, or anything that you want to appear, no, so these are called elements, right? So for example, the parts of HTML program, you very well know it has, so parts of the HTML program, you know very well, it has a head and body, right? So head is a place where you write all the information, and then body is the place where you put everything that you want in the web pages. So I'm not going to spend much time teaching you the basics of HTML program. I'll directly show you the HTML program that we are going to use today. Very simple. What we have done in this HTML program is, we have created two buttons. You can see the buttons here. So we have created two buttons, one button here, second button here, and we have named it LED on button and LED off button. And every time when you press that button, it's a submit button. So what it submits is, the first button submits a value 0, and the second button submits a value 1. It's as simple as that to understand. So we have created a form. It's a form. In the form, we have two submit buttons. One submit button LED on, when you press, it submits a value 0 to the server. And then the other one submits the value 1. As simple as this. So remaining everything are all makeup, right? Starting syntax, HTML, head, you give a name, and then you give a background, you give a title to the page and everything. The important thing is just here. So this is the important thing. So all you have done is created two buttons, submit buttons. When you press one button, it submits a value 0. And when you press another button, submits a value 1. So this is with respect to HTML program. So next thing, this is, so you can see how it works here. So first time when you press LED on button, so what it submits is, it submits a value 0 on the taskbar. So it submits a value 0 when you press that button. So when you press LED off, it submits a state or value as 1. So this is easy to understand, right? So we are pressing two buttons and it submits a different values every time you press. So now next step is, you have to program this node MCU. You have to make this work, right? So next step is, you have to create an access point on this node MCU. So how to create, what is an access point? First, you should know that. So access point is basically anything that provides the network entry, right? So when you want to get connected to a network, so basically you will need the SSID, that is the name of the Wi-Fi, and the password, correct? So that is basically the entry to the internet, entry to the network. So these are called access point. So node MCU creates that access point. It gives a username and it gives a password for you to get connected. So it is an access point, right? So now in the overall process, so your node MCU is going to be the server, and your laptop or your mobile phone is going to be the client. And what happens is, your laptop says, I want to get connected to your network. And what happens is, using that name and password, if you type, it will allow you to get connected into the network. So when you enter the password, it will allow you to get connected to the network. And next, what happens is, so this is access point which provided the network. And then in our case, we are going to create that access point using programming, using software. So it is called software access point. Remember that it is called software access point. So now server. So who is the server in our case? The node MCU microcontroller board, where all the resources are available. That is, you can type any number of HTML pages. You can store it in the node MCU in the local server. So it is called server. Server is someone who has all the resources with them. Correct? Understood? And every server will have a address. So all the address for all node MCUs are the same. 192.168.4.1 is the IP address of all the node MCU, not just this node MCU, all the node MCU. Remember that, correct? So now server is a place where you have all the resources, correct? So if anyone wants that resource, you can go to that address, you can ask for that resource, correct? And if the server has permission to give that, they will definitely give it to you. And now client. In our case, the client is the laptop, the browser in the laptop. So you don't have anything. What you do, you type that IP address, you go to that particular resources available, you ask for something. I want the LED page, I want the torch page, I want the buzzer page, and so on. What does the server do? It gives. Here, take it up. You go, you access, you have the access, you do whatever you want with the page that is there available on the server, right? So now, after the access is given, the client submits a request by pressing the button. I want LED on. So what happens is, when the moment you press the button, this information is communicated to the server, and on the server, the action is happening based on whatever you are submitting from the client. So this is the overall background process. So how do you do it in programming? Understood the overall process? So how do you do it in programming now is very simple. Steps is, first you have to make the node MCU a server, and how to make it a server is using simple library, and no need to memorize everything here because everything is library and you can do it very simple. The steps are very simple. First, you have to make this node MCU a server. You have to create an access point, that is only then you can make devices getting connected to it, that is making a password and making a name to this access point. And then you should know what is the IP address of this server, so that people can come to that address and access it, get that IP address, and then handle the client server communication. So whatever request the client gives, give the resources, and based on the request given by the client, take action. That is the whole thing. So now how do you do this? As I said, don't want to by heart anything, don't want to memorize anything. It is very simple. Remember the process. You can also do it later. So these are the steps. Just remember the steps alone because we don't have enough time to go in depth about the programming. But remember the steps. I can share you the programming later after the session, or I can give you links where you can get this programming. That would help you to work after the program, after this particular session, correct? So now the steps, very simple. First step, as I said, create a server on the node MCU. And then second step is create an access point. Access point is basically giving the Wi-Fi a name and the password for the access point. That is it. And then you need the IP address. So you ask for the IP address with a particular command. It gives you the IP address. Get that IP address. And then start the server. Make the server run. And then whenever some requests come from the client, take that particular action, and you have to keep the connection alive. So these are the simple steps to make this application work. Create a server, create an access point, find the IP address, start the server, and take action based on requests, and then keep the connection alive. So how do you do it in programming is very simple, creating a server. So remember these things alone. When I show the program, it will help you to understand why I have used each and every line of code in the project. Got it? So how do you create a server using the library that I mentioned? So creating a server is very, very simple. So this simple function will make you create a server in the name of server. So as I said, we use ESP8266 Wi-Fi library. So the command to create a server is ESP8266 web server. After that, you can name your server. You can give any name you wish. I have given it server as the name. Clear? First step, creating a server. Server is the name of the server that we have given. Second step, creating an access point. As I said, it is a step where you give a name to the Wi-Fi. All the Wi-Fi in your home, right? You have given a name and it has a password, right? Same thing we are doing it here for the Node MCU. So Wi-Fi dot soft AP within bracket give the username and password. But within bracket, if you give, it won't be nice. So we will use variable declaration or constant declaration and then call that and put it here. That is how it will be done. So Wi-Fi dot soft AP. So we use a constant character name array. ESP8266 is the name of the name you want in the username. And for the password, you have to give an 8-digit password without fail. And it can be alphanumeric, right? So whatever you write in this 2 lines of code, it goes and submits in that particular function and it creates a access point. Clear? Wi-Fi.soft AP within bracket username comma password will create a access point. Next step, finding the IP address. Wi-Fi.soft AP IP within bracket. If you call this function, it will get you the IP address of the server. And after getting that IP address, print it. Only then we can see it serially, right? What is the IP address? So what I have done is I have used a variable IP address. So it is a data type, like how integer, float, character, everything is there. So we have a data type called integer. So we have it. And then I'm getting the IP address, printing it serially so that I can see what is the IP address of this particular server. Clear? So far clear? Now next step, start the server. One simple program, server.begin. That starts your server, server.begin. And then take action based on request from the client. Very simple. So client will give you a request. You have to give the response. So it's basically server.on is the request function. I need the LED page. Is the request coming from the client? Server should respond with respect to what you want to send. So for example, in this case, LED is the request. The server is giving a LED function to the client. So what is there in the LED function is the overall HTML program, whatever you have typed should be stored in that function. And whenever the button is pressed, it should take the corresponding action. So that is written in the overall LED function. So now how to write that HTML program in Arduino programming or C programming is copy everything, paste everything, but there will be a lot of double quotes within HTML program. So the C programming compiler will take it as a string. So in order to avoid that, you have to prefix everything with a backslash. So if you do this, you will be able to send all the HTML program to the Arduino programming to a variable myHTML as a single string. So that would do the job. So now let's go directly to the LED function. So whenever request comes, so what the server does is it sends the HTML program with the response 200 as OK. That is OK response. And then I'm sending you the HTML file and the name of the string or the file is myHTML. So this is what happens. So based on whatever you click, then action should happen, right? So we are checking the argument. So what value is submitted? If 0 is submitted, turn on the LED. If else, anything else is pressed, turn off the LED. That is what is happening. And how to keep the connection alive is server.handle client. So these are the simple steps you have to do if you want to create a project through which you can control devices using a web page. What are the steps? Don't want to remember the programming. It's easy, it's library, but at least you should remember the step. So let's recap the step. So the first step is creating a server. How do you create a server? How do you create a server? So it's there in your screen. You can see ESP8266 web server.
Given any name.
Name of the server, exactly. The second step, anyone remembers the second step?
Create access point.
Yes, exactly. You have to create an access point. How do you do it? Wi-Fi.soft AP. Yes, Wi-Fi.soft AP.
Username, password.
Password. And The third step is finding the IP address. How do you find the IP address?
IP address
Soft IP. This is a function that will get you the IP address, but you are going to print it using a simple IP address data type, and you send it serially so that you can see when you are working, correct? And how do you start the server?
keep
Server
the connection.
begin, exactly. And action based on request is very simple. Server dot on, request will come, and you will have to give the response as some function. Yes, so the function consists of what? It consists of the HTML program that we created, and also the argument. If this button is pressed, you have to turn on the LED. If this button is pressed, this has to happen is written in the LED function. Clear? Here is the LED function. So the entire HTML code, the response, that is server.send, okay, I'm sending you a text or HTML file, and it is a my HTML, the entire code that you have written. And whenever there is an argument, 0 is pressed, turn on the LED, 1 is pressed, turn off the LED. And how do you keep the connection alive? Server.handle
Client.
function. If you have this, your job is done. Your project will work like you can control anything in the local network. So now let's go and quickly program this and see how it works. So where is the Arduino? So it's going to take a lot of time for us to type, but whatever I have told you, it is here. So you can just go through it. So the name of the library here, and then the username and password for the access point. And this step is the first step. What is the first step? What is the first step?
Creating server.
Create a server.
Exactly. And then the remaining. So creating an access point. Yeah, creating an access point is here, and getting the IP address is here, and printing to see what is the IP address, and then action based on client request is here. And then this is turning on the server. Got it? And this is keeping the connection alive, and the overall function, LED function, the overall HTML code, and the response and the argument is here, correct? So now let's quickly compile this file. Okay, compiling. Let's upload. Okay, it is getting uploaded. %. So once it is uploaded, let's first check the IP address alone. And in this case, the baud rate is 115200. Let me reset so that I get the IP address. Can you see the IP address? As I said,
Yes.
it's a one for all
Yes,
the.
sir. 192.168.4.1.
Yes, exactly. So the now next step is I have to connect a client to this. So the client that I have taken today is my mobile phone. Let me project it so that you guys can see the steps involved. Okay, so let me project it. I don't know why my. So you'll be able to see my phone screen soon. Here it is. So the next steps are very simple. So first step is you have to go and get connected to that network. So go here, and then you see Lema IoT, right? So that is the name of the access point that we created. So click it. It should get connected to that. It won't have any internet because we don't have anything there. It's a local network. And then go to the browser. Okay, let me close all the scores, checking everything. So now you are here, and as I said, 192 dot 192.168 dot slash LED is the request that you wanted to get. And let me turn off my mobile data. It won't work if the mobile data is turned on. Can you see the web page that was there in the NodeMCU server? Yes. So now,
Yes, sir.
okay, let me. Now next step, let's see if it is working based on the request. So I'm going to press LED on. The LED turned on. Can you see? When you press LED off, you can see on the address bar here, on the address bar, you can see the state value changed to 1 and the LED turned off. And when you press LED on, the state value changed to 0 and then the LED turned on. And this is within the local Wi-Fi network. So you can imagine your local Wi-Fi network range, right? Within your home, you can literally control this one using this web page. Any doubts?
Good morning, sir.
So anyone has a doubt so far?
Hello, sir.
Yes.
So this device means how node MP cost will be?
300 to 350 rupees max.
Okay, sir. Whether we can make this arrangement for our whatever the home surveillance means in home for the LED fan and gas, we can make the means we can able to write the program for them.
Yes, you can do it. You can completely automate your home also. You would need some sensors and relays to do it. Actually, the second half of today's session, I'll teach you how you can automate your bulb at your home, like using Google, not just without internet like this, not just within your home.
Sir?
You can
Sir?
get control from anywhere.
Sir, Parthiban, sir.
Yes, sir.
Shall we break for half an hour and then, because you have 2 sessions, correct?
Yes.
So the next session we can start off by 11:30, sir.
30.
So
Yeah,
that it can go till 12:45 or 1, sir.
okay. Okay.
Sir, I am
Okay.
having a query.
Yes,
Queries, yeah, please.
Okay.
Because,
I'll stop with this query. Maybe,
yes, sir.
we'll
Yes,
wind
sir.
up with the-
Yes, sir. Yes,
Those
sir.
who want to leave, they can because it's a tea break. So
Yes, take a break. We'll rejoin again by 11:30. Thanks, everyone.
okay, sir. First of all, thank you so much. It's very informative session as I am not from the CS background. I am from electronics and communication, and I started recently to work on Arduino. So
Okay.
first of all, thank you so much that whatever I am having a doubt, you have cleared a lot.
Oh, thank you.
And I request Sairam group of college that they are going to upload your PPT also, but please upload this recorded lecture
मैं सर
also.
अभी आपका थोड़ी देर यूज करूंगी.
Presentation, it's Lema's property. It's IP of the company. So I'm not sure if I would be able to give the presentation to you guys, but I can definitely help you with the code that is required. And also the recorded session, I'm damn sure Sairam will definitely help you with that.
So because means without the recorded session, it will be like that we are just going through the notes or from the books. So
Okay.
through the recorded session, it would be better that whenever we got stuck up in some point, so we can go back to the session and we will access that. And as while your PPT was going on, so either I can concentrate at what you are saying, or either I can write it down. So it would be great, sir, if the PPT is also provided by the Sairam group.
Okay, I'll definitely make us at least bits and pieces of the. Also, if you are someone who is really interested on learning the thing, please wait till the end of the session. How Lema Labs as a team have developed courses that would help people like you to learn technologies like robotics, IoT, everything from anywhere right now. We are doing all this thing online as well. So you can sign up for that course, and then, with much assistance, you can also do that.
Okay, sir.
Madam? Madam,
Sir,
madam, can you able to hear me? Leena, madam?
Hanji, ma'am.
Yeah, ma'am, all the sessions are recorded, ma'am. Nothing to worry. We posted in our Google Classroom as well as the AACT portal also. That is the mandatory thing, the instruction from AACT, ma'am. So nothing to worry about it. So every session is most recorded session.
Okay.
Okay.
Thank you. Thank.
Will get benefited.
Okay.
Yeah,
Sir, the question is that you told us how LED work. That that at the one point, which is the anode, right? We are giving them the 5 volt or 3.3 volt, right?
Yes.
And at the another point, we are giving them the 0 volt, which is connected with the microcontroller. This thing you have told, sir.
Yes.
I just want that once, if you will repeat this point once again.
Okay.
With those slides and those LED programs like. And moreover, during the programming, when we use the semicolon or some curly bracket, are these like in a language as we are using the punctuations?
Yes, exactly.
All these are exactly same.
So this is your doubt, right? Let me first clarify this.
Yes.
So
Sir, I'm not getting your voice properly.
doubt, right? Can you see my screen?
Yes, sir.
So now this is when generally an LED works. When you have a higher potential to the positive terminal and the lower potential, preferably ground to the cathode, the LED turns on, correct?
Right.
Yeah, the same thing happens here. So this positive terminal is connected to 3.3 volts on the microcontroller board. The negative terminal, here is the negative terminal that comes to the pin number 16.
Okay.
Now, if you want to turn on this LED, it has a positive supply on the positive pin. The negative pin should have a 0 volts as potential, correct? Basically
Right.
this one. So when you, how to give that 0 voltage? By making that particular pin value low. So when you write a program, digital write pin 16 comma low, in the microcontroller, what happens is the 16th pin, voltage at 16th pin goes as 0 volts. That will turn on the LED. Okay. So now similarly, if you want to turn it off, basically here, instead of 0 volts, if you again connect to 5 volts, will this LED glow?
No.
No, because there is no potential difference. So
Right.
same thing here. When you make this pin high, that is high in node MC is 3.3 volts. When you make it 3.3 volts, that is high, the LED will not turn on.
So this 3.3 volt is connected with
the
what?
negative, the negative pin. That is where the negative pin, the cathode is connected.
Okay. So this LED is connected with Uno board you want to say, na?
The pin number 16 here.
Pin number 16. Okay.
Yeah, pin number 16. Yeah.
Okay.
Got it?
Yes, sir.
Okay. We'll take a quick break, and end of the session also I'll help you
Thank
clarify.
you, sir.
Yeah, sure.
Parthiban sir, you can break yourself, sir. Thank you, sir. Thanks for all. We'll again
Sure.
come
I'm
back
looking for a
come
break.
back by 11:30.
I'll have a coffee.
Have a break, sir. Yes, sir. Please.